Hello, everybody. Welcome to another episode of Coding with Culp. Today's a great day to learn how to code. Today's lesson, Python Lesson 2, is reverse guess the number. Let's go over the learning goals of today's little project that we're going to do. So our learning goals is that by the end of this video, I want you to understand what an algorithm is. I want you to understand what a binary search is. I want you to be able to compare it to a couple other searching methods, primarily what we're going to call a sequential search method, and also a random search method. I want you to be able to import the random module and use what we call the random integer or randint and the choice functions from that module to add in a little bit of randomness into our program. And I want you to learn just a little bit about lists and how to create them. These short little lessons aren't really designed to make you a complete expert on a particular subject in Python. I prefer to teach things and to learn things by actually doing something. And so these are designed to teach you Python little by little by actually writing programs that do something. So in today's project, we're going to do a reverse guess the number. So in most guess the number programs, the computer chooses a hidden number, like between 1 and 100. And then we enter our guess, and the computer tells us if we are right or if we're wrong. It could also tell us whether our guess is too high or too low. And then we, the human, keeps guessing until we guess the number. There's no real intelligence on the part of the computer. It just simply compares to find out if we've gotten the number right and tells us if we did or not. In reverse guess the number, we, the human, are going to think of a number, and then the computer is going to guess, and we're going to give the computer feedback that'll allow it to refine its guess until the computer guesses our number. Now, the way we're going to do this is we're actually going to build this program up from something that's not a really good way to do it, kind of a naive way to go about this problem. And we're going to build it up through 2 or 3 iterations into something that's actually really, really good and can find the number in just a few guesses and does it really, really quickly. So without further ado, let's go ahead and get started and let's write some code. Well, before we write some code, I would really appreciate it if you subscribe to the channel. I know I'm a new channel. I know I don't have a whole lot of content, but I'm going to be producing a ton of content as we go along. So I'd really appreciate it if you subscribe to the channel. I'm also going to have some giveaways here pretty soon, which I'm going to be giving away some Raspberry Pis and some microbits to subscribers of the channel. So I'd really appreciate it if you subscribe. So once again, let's get to writing some code. Okay, we're going to be using Python 3, and I'm going to be using a Raspberry Pi and a integrated development environment called Genie. You don't have to have a Raspberry Pi. The stuff we're writing is going to work on any system that'll run Python. It's just straight, average, everyday, ordinary Python 3. Nothing special about it. I do like the Raspberry Pi 3, or the Raspberry Pi 4. It's pretty fast, and the Raspberry Pi was, of course, designed to teach people coding. In addition, Raspberry Pi is fairly inexpensive, and the great thing about it is when you set it up, the Raspberry Pi operating system comes with everything that you need pretty much pre-installed, including Pygame, Python 3, and Genie. But let's go ahead and get started. Now, I already have the first program written. I'm going to erase it. Oh, nope, this isn't it. So what we're going to do is we're going to start a new program here, and I'm going to save it. So I'm going to go File, Save As, and I'm going to call it, I'm going to enter into my coding directory here. So if you don't have one of those, if you're using Genie Raspberry Pi, you can just click on the plus icon here for a new folder, name a folder coding. And I've got a little project here called Guess the Number, another folder. And I'd actually written, this is like my third time recording this video because I've had severe technical issues. I'm all new to this, so first time I recorded it, I had absolutely no sound throughout the entire video. Next time I recorded it, I had some really bad stuff. So anyways, hopefully this time works. So here we go. So we're going to start, I called mine guessnum.py. Guessnum.py. So I don't think you saw that, but what you're going to do is you're going to go File, Save As, type right in up here, guessnum.py. The .py is really important. It tells Genie or whatever integrated development environment you're using that this is a Python program, and so it's going to color code and format and indent and do everything you need it to do based upon the fact that it's a Python program. Okay. So let's get started. First thing we're going to do is we're going to import the random module, and we're going to import the time module. These are two modules that we need to do a few things. The random module provides us with some functions to get some randomness into our program. We'll take a look at that in just a second. The time module has some, well, once again, time-related functions. If you don't know what import does, all import does is it essentially makes available code that somebody else wrote that we have access to. Python comes with a ton of modules already written that we have access to, and random and time are two standard Python modules that we're going to use. All right, so in this very first program, we're going to take a really naive approach to solving this problem. All we're going to do is we're going to set up a loop, and each time through the loop, the program's going to guess a random number between 1 and 100, or from 1 to 100. Ask if that's our number. We're going to give it some feedback and say yes or no. If it's yes, it's going to end. Say, congratulations, I got it right. Or if it's no, it's going to go back up, choose a new number, and go through the process again. So let's print out a little prompt for the user. Let's see here. Think of a number between, or let's say from 1 to 100, and I will try and guess it. Okay, and then what we're going to do, we're going to use our first function from the time module. Time.sleep. What time.sleep does is it pauses right here at this line for the number of seconds that is in the parentheses in the function call. So sleep is a function that is in the time module. And notice a couple of things when we call it. We use the name of the module that it's coming from, time. We use a dot, that's important, must be there, and then the name of the function. And then we gave whatever parameters we needed to into that function. In this case, we're going to sleep for 3 seconds. So it's going to pause for 3 seconds before it actually starts into the loop of guessing numbers. Now, I'm going to set a variable called guessed, and I'm going to set it initially equal to false. So what this is, I've created a variable called guessed. Guessed is going to be a Boolean variable. If you don't know what a Boolean variable is, a Boolean variable can only hold two values, either true or false. I'm initially setting it to false because what this variable is going to do is it's going to keep track of has our program actually guessed the number. And of course, right now that's false. It hasn't. So it's going to start out as false. And then what I'm going to do is I'm going to set up a while loop. I'm going to say while guessed equals false. And then I'm going to do a bunch of stuff in the while loop. Let me write some code, then I'll explain the while loop, okay? I'll explain what I'm doing. Let's see here. Let's say, is your number did I do that right? I did. Okay. So let me explain what we've done so far. So we're going to do a while loop. If you're not familiar with what a while loop is, a while loop does a bunch of stuff while this test is true. So what's going to happen when it hits this while, it's going to make this test. Is guessed, our variable guessed, Is it equal to false? If that's true, in other words, if it's true that guessed is equal to false, it's going to do all the stuff that it's indented. So I want you to take a look at a couple of things. First of all, notice the double equal sign in the while loop testing for true. That's a big hang up with a lot of new programmers, and it's a common mistake. When you're testing if something is true or false, you use the double equal sign. The single equal sign is an assignment statement. The single equal sign assigns a value to something. In this case, for example, right here, the equal sign assigned the value of false to guessed, this variable guessed. So now this variable guessed, the box in the computer's memory labeled guessed, is set equal to false. One other thing I want you to take a look at, notice it's color-coded in blue and it is uppercase. If I put it in lowercase, notice it's no longer color-coded in blue. In Python, our true and false have to be uppercase. All right, now let's look at this while loop. Once again, a double equal sign test for equivalency. Notice our while loop also ends in a colon. That's another common mistake. So then what we do is we make the guess. I set up a variable called guess. I could have called it anything I wanted to, but because it is the computer's guess, I called it guess. That makes sense. And we do the random.randint function. So once again, this is the module name that it came from, random, the dot operator, and then the actual function name, randint. And what randint does is it gives us a random integer, an integer being a whole number, in other words, not floating point. It could be negative if we wanted to, but in this case, it's going to give us a number from 1 to 100. The low value that we want all the way through to the high value. This is inclusive, so it will include 1 and it will include 100. Next, what we're going to do is we're going to ask the person, is this your number? And we're going to assign what they tell us into answer. So input, and by the way, I go over input in my first video on Python, so you might want to take a look at that if you're unfamiliar with input. But what input does is it prints out a prompt. The prompt is actually optional, but it prints out this prompt. In this case, it's going to print, is this your number? Or is your number. Now notice, this is a little confusing to new programmers, especially programmers new to Python. Guess holds a number, an actual number, like 27 or 49 or 100 or 10. What we're doing here is we're concatenating. So we're saying, hey, print this out. And I'll explain this \n in just a minute. I know you're probably going, what is that? We're going to print this out. Plus, we're going to print this. But you're probably wondering what this str is. Well, you see, guess is a number. And what we're trying to do, what the plus does, is it adds two string variables together. String variables, and I cover this also in the first video. So I urge you to go look at the first video if you're not quite familiar with variable types. So what it does is it converts guess temporarily into a string so that it sees it as text. So if the number was 47, it sees it not as 47, but as a string of alphanumeric characters of 4 and 7. Then it adds in this. Question mark, yes, no. Let's run it real quick and see what we get. Make sure I haven't committed any errors either. All right. Thought I ran it. There we go. All right. Think of a number between 1 and 100. I'll try to guess it. Is your number 13? And I'm going to hit no. Is your number 61? Yes. Now, this is never going to end because we haven't actually tested as to whether the user got it right or not, or the computer got it right or not. I'm going to hit Control-C. I'm going to fix one thing. We need a space right here. Oh, I wanted to talk about spaces real quick. So you'll notice I put spaces on the equals. Those are actually optional. You don't need them. You can go like this. I put them in there. It's just a matter of preference, just because I think it's more readable. Some people don't, but you don't have to have these here. Now, this indentation after the while is absolutely, positively necessary. Python uses indentation to denote blocks of code. What's going to happen, you'll notice, it just kept asking us, it guessed a new number, is this your number, guessed a new number, is this your number? So what while does is it keeps doing the stuff that's indented after the while loop until this test becomes false, or this is no longer true. So now, let's see if we can get some input as to whether they got it right or not. So what we're going to do is we're going to say answer equals, and I'll explain this in just a second. I'm going to type out some code and then I will explain it. Answer dot, let's see, we're going to convert it to uppercase. I'll explain why in just a second. And then we're going to go into some if statements. If answer, equals yes, or answer equals. You know what? I am gonna do that. I'll do it a different way in just a second after I explain this. And then let's see here. How about we do this? Darn. Okay. I will try again. Time.sleep 2. And this is actually going to finish the program. Notice I unindented this, and I'll explain why in just a second. Okay. So, the person has answered. They're going to type in Y, or they're going to type in. What we're going to do is we're going to convert it to uppercase. So what this does, the name of the variable, in this case it's got to be a string variable. It's got to hold text. This returns that converted to uppercase. And then we're going to reassign it back to this variable that we called answer. So now answer is going to be converted completely to uppercase. And I do that so I don't have to test here. I don't say if answer equals Y, uppercase Y, or answer equals lowercase y, or answer equals uppercase yes, or answer equals lowercase yes, or any combination of that. It's all converted to uppercase. So now what I do is I say, hey, if whatever's in answer, this variable we called answer, if it equals yes, remember double equal sign, if it equals uppercase Y, or if it also, or if it or if answer equals all uppercase yes, well, the computer got it right. We're going to set guessed to true. So now it's going to go all the way back up, and guessed is going to be equal to true. So now this test fails. Guessed is no longer equal to false. And what will happen is it will then skip. It will leave the while loop and go all the way here to the next unindented line after the while statement, in which case this is print. I told you I would guess it. Now, if the user doesn't enter Y or enter yes, we're going to assume that the computer didn't get it right. So we use an else statement. So we say, if this isn't true, else let's do this. Now you're probably asking, oh, notice the else also has a colon, and it is indented. So what will happen for the else is it will do everything that's indented after the else. Okay, it could be 2 statements, it could be 20, it could be 100. I recommend you keep it short. So it's going to do everything after the else. So if this isn't true, okay, if this doesn't test out to be true, it's going to drop down to here and do this. Now, I could have done this instead. I could have tested if, let me go back to insert mode, if answer equals no or in, or answer equals no. And this would accomplish exactly the same thing. Exactly the same thing. If we answer yes, this gets executed, sets guessed equal to true, goes back up to the top of the while loop. This test fails. Guessed is now equal to true. So then it goes all the way down here, skips everything, and does this. If we enter in instead, or we enter no, it does this stuff. Says, darn, okay, I'll try again. Sleeps or pauses for 2 seconds, goes back up. This test, guessed is still equal to false, so it does all this again in this order. But here's the deal. I don't need to do this test. If we didn't answer yes, there's only one other possibility. If the computer didn't guess it, the only other possibility is they didn't. So we can use an else. All right, let's run this. This is all we need. It's going to work, unless I made a weird error somewhere. Think of a number from 1 to 100. I will try and guess it. Our number is going to be 5. Okay, our number is going to be 5. So, no, it didn't get it. Darn, I'll try again. 98, no, not going to do that. Nope, still didn't get it right. 33, no. Okay, 7, that's getting close. Getting real close. It's only 2 off, but unfortunately, that's not the right answer either. We're looking for a 5. Now, you're probably kind of understanding what's wrong with this right now. It can take a long time to guess. And the fact that we have the entire range available each time it guesses is problematic. Every time the computer takes a guess, it has a 1 in 100 chance, or a 1% chance to get it right. So every time it takes a guess, there's only a 1% chance it's going to get it right. And, oh, look at that. It was 4. That was close. And that chance is never going to get better, ever. It's a 1% chance, 1 out of 100, every single time, because we're not eliminating any answer choices. And in fact, the first time I made this video, I told you I had to shoot it a couple of times. 100 came up 3 times in the first 10 guesses. Oh, there it is. It got 5. I don't know how many guesses that took, but let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10... 11, 12, 13, about 14 guesses. So I think you can see that this isn't a very good way to do this. And that if we were using this as a search algorithm, just randomly guessing within that range, there could conceivably be a case where it takes 1,000 guesses to get it. Now that's probably not very likely, but it could happen. So what we're going to do now is we're going to change our algorithm. What we need to do is we need to basically act on the feedback that the user is giving to the program. So what we're going to do is we're going to eliminate numbers. Every single time the computer guesses a number, if it's wrong, we're not going to guess it again. So what we're going to have to do is we're actually going to have to keep track. We're going to have to literally keep track of the numbers we've guessed, or we need to eliminate numbers, and that's what we're going to do. So this program is going to change quite a bit. So what we're going to do is we're going to create a list, and I'm going to, if you're not familiar with Python list, first thing I'm going to do is I'm going to create a empty list. And then I am going to populate that list with numbers. I'm going to show you in just a second a little bit about lists. All right, so I'm going to make an empty list, and I'm going to say for num in range. Now I'm going to build our list. For num in range 1 to 101. Num list dot append num, and then just to show you, I'm going to print out the list. So this is the first part of our change. We've got to make a list. So all a list is in Python is literally what it says. It's hard to define it without using the actual word list in there. A list in Python is literally a list of data. And so let me just kind of show you here. Let me open up a terminal window. Let me open up Python. Okay, let me create a list. I know, groceries. Let's say groceries equals eggs, milk, and bread. So now this variable, this thing we've created called groceries, is a list, and I can print it. And there is a lot you can do with list, and I'm not even going to scratch the surface hardly on what you can do with list. Lists are one of the most powerful features of Python. So you can see that it's equal to eggs, milk, and bread. Now I could add to that list. Watch this. I could say, let's say my wife calls me and says, hey, I need you to pick up, let's say, eggs, milk, bread, and apples. So what I can do, I can add to it. I can say groceries dot append, and we're gonna add apples. There we go. Now it's printed out again. Oh, by the way, if you're working in the Python 3 REPL or the Ubuntu or Raspbian or Linux command line, you can just press the up arrow key, and it's going to cycle through the last things that you did. So print groceries. And there, we got apples on there. Now, the great powerful thing about list is you can also refer to the elements in that list by their position. Watch this. By the way, I didn't have to use print. I could just do this, and it's going to print it in the REPL. So if I use these brackets, and let's say I do this, groceries 0, that's eggs. Everything in the list has a position, and we start counting at 0, and that's another one of the big hang-ups that new programmers have. We're going to start at 0. So eggs is in position 1. Eggs is in position 0. Milk is in position 1. Bread is in position 2. Apples is in position 3. But notice the length of this list, okay? The length of groceries is 4. It has 4 elements in it. But element number 1 is in position 0. And that's something that new programmers oftentimes have difficulty with. All right. So what we're going to do is we're now going to go back to our program. I talked a little bit about list, and so let's go back here. And so what this does, let me explain. This is a for loop, and I explained for loops in my very first video if you want to go check it out. So what the for loop does, well, let me come up to here. What I do is I create an empty list. That's what the open and close brackets does. We create a variable called numList, and we make it an empty list. Now I'm going to populate that list. So I just do a range. I do a for loop. I say for num in range 1 to 101. Another common error that people forget is that when you're using the range operator, the range function, it's not going to go to 101. It's going to go to 1 short of that. We're going to start at 1, and the last time through the loop, num is going to be equal to 100. Then what we do is we say numList.append. Append, if you remember, adds to the end of the list. So the first time it's going to add num, it's going to put 0 in our list, and then 1, and then 2, and then 3, and then 4, and then 5, all the way up to 100. So we're going to have a list of numbers from 0 to 100. And I'm going to print it out just to show you. We're going to do the same thing. We're going to say, think of a number from 1 to 100. That part doesn't have to change. Okay, let's keep track. Let's keep track of the number of guesses. We're going to set num guesses equal to 0. because we haven't done any guesses yet. And we're going to do the same thing. We're going to keep track with guessed equals false. Okay, now, right here, we're not going to, excuse me. We're going to get a random number a slightly different way. We're going to use random dot, I think it's called random dot choice, yeah. Notice it's completing it for me. And we're going to take it from num list. What random dot choice does is it takes a random element from this list. It chooses a random element from the list. So in the case of our list, we've got a list of numbers from 1 to 100. It's going to get us a number between 1 and 100. All right. Let's see. We're going to do the same thing. We're going to say answer equals input. Is this your number? That doesn't need to change. Answer equals answer dot to upper. So now what we need to do, num guesses. Notice how it's command completing. I can press tab. Plus equals 1. Let me explain a couple of things if you don't know what the plus equals means. It's a shortcut for num guesses equals num guesses plus 1. Programmers are lazy, so we invent shortcuts for stuff, and so I'm going to do plus equals 1. So all it does is add 1 to num guesses. We've taken a guess, we're going to add 1 to it. Okay, I think the rest of the program is maybe the same. Yeah, I think it's the same. Time.sleep. You know what? To prove to you that we've got to num list dot remove guess. Okay, so what's going to happen is if the guess is not correct, if we say no, it's not right, we're going to print out darn, okay, I'm going to try again. But then what the remove operator does, or the function, is it removes this item from the list. For example, if we come over here to our grocery list, let's remove eggs. So all we do is it's the name of the list, okay? The name of the list, groceries, groceries, dot remove, and then the item we want to remove. Let's say my wife calls me up and says, oh, I forgot we actually do have milk. So I'm going to remove milk. Now, let me print out groceries, and there's no milk there. One thing you have to be careful of, though, is that if the item doesn't exist, for example, let's say I thought I had, bagels on my list. I want to remove them. Going to get an error. So you have to make certain that the item exists, and there's ways to do that. It's beyond the scope of this video. I will probably do a video that goes into list in depth. This is just to kind of familiarize you with them. So what we're going to do is we're going to remove the number that was our guess. We're going to sleep for 2 seconds and go back and do it again. So now let's do this. It's a print. It took me num guesses to get it. Okay, I think this will work. Oh, there's one other thing I wanted to say. For those people who do know Python, they're probably screaming right now. There's another way to build this list right here that we did. It's called list comprehensions. I'm not going to go into it right now. I think when we change the program for the next part, I might. But for right now, I think most people can understand how this list was built. Whoops. Most people can understand how this list was built. It's just a simple for loop. Each time through the loop, num gets the value. Okay, as it iterates through there, it's going to start out at 1. Then num's going to be equal to 2, then 3, then 4, then 5, then 6, and 7, etc. and we just append that number to the list. All right, let's see if I got this right. We'll find out soon enough. Okay, so what I did was I printed out the list just to show you. It is a list from 1 all the way to 100. So we're going to stick with 5. 5 is our number. Is your number 46? No. Darn, okay, we'll try again. Is your number 91? I want to press Control-C. Let me press Control-C. I'm ending it because I forgot I wanted to print num list here. I wanted to show you that that number is being removed from the list each time. So let's try it again. All right, our number is still going to be 5. So is your number 48? No, it's not. Darn, I will try again. Notice right here, 47, 49, 48 has been removed. So the first time it had a 1 in 100 chance of guessing the number. Now the second time it has a 1 in 99 chance. So the odds of it guessing the number have gone up. Number 91, no. And you'll notice 91's missing. So let's just keep going. So you can see this is better. Each time it takes a guess, the odds of it guessing our number go up. But still, it's not very good. At worst case scenario, it's got to go through all 100 numbers to guess our number. And there's a possibility that it could. It's not likely, but it could very well take 100 guesses. And that's just a list with 100. What if we had 1,000,000 numbers? It could very well exhaust the entire possibility of that list before it found the number by guessing randomly. And it's taken a while here. But once again, each time it gets a little bit better. It's got a little bit better chance, and it improves its chances by 1% every single time. I'm going to keep going until we get the number here. Hopefully. Maybe. Now, one time I was running through all this, and I got so used to hitting no that when I did guess my number, which was 5, I think I'm going to stick with 5 each time just to be consistent. I actually hit no because I was so used to hitting in. But 5 is still in there. I don't know what our odds are right now, but they're still much better than the beginning. Although you'll notice that I think I've guessed more times already than the first time, where we just completely randomly guessed each time. That was taking longer than I wanted it to. All right, I'm going to give it 5 more guesses. If it hasn't guessed it, we're going to go on. 1, 2, 3, 4, 5. Let's give it 5 more. 5 more. Oh! I did it. Did you see that? I got so used to hitting no that when it gave me the right answer, I hit no. Let's say yes. So it took 46 guesses to get it. Actually 45 because we went one too far. So you can see that that's better, but still it's not great. So it'd be better. What would be better is if we gave some feedback, if we were too high or if we were too low. So let's change our program so that we give it that kind of feedback. Oh, one other thing. We're not going to be using the list anymore. We won't need it. I wanted to show you the other way to build a list. And it's called a list comprehension. It's kind of, I consider it an advanced topic if you're new at Python. But what we could have done is we could have said num list. So this pattern right here of entering into a for loop and appending things to a list is so common that Python has a shortcut. So I can say num list. Let's do num for num in range 1 to 101. So it's actually almost the same. What it does, notice it's in brackets. The for loop that we did is inside the bracket now. And so all it does is it says num for num in range 1 to 100. So num is going to get the value of 1, 2, 3, 4, 5 as it iterates, but it's going to add it to the list each time. It's basically just a shortcut for doing this. If you don't understand this, it's okay. List comprehensions can be a little bit confusing at the beginning. Once you've worked with Python a little bit, I think you get the hang of them. So don't worry about it if you don't quite understand what this does. All right, let's go to the next thing. Let's give our program some feedback. And like I said, we're not going to need the list stuff anymore, so let's get rid of it. All right, so we're going to do the same thing. So what we're going to do this time is we're going to give it some feedback. We're going to tell it whether we're too high or it's guessed too high or too low. And what we're going to do is we're also going to keep track. Because another thing is, once we say, hey, that guess is too high, you never want to guess above that number again. So we need to keep track of that. And so let's call, well, let's call it low guess. And our low guess is going to start out at 100. This is the lowest number that we can guess. And our high guess is going to start out equal to 100, the highest number we can guess. So the whole range is available to us. Low guess is 100, and high guess is, 1, and high guess is 100. All right, so same thing, guessed equals false. Now we got to go back to generating our random number with randint. However, what we're going to do is we're going to do, our range is going to be from low guess. That's going to be the lowest number. And our highest number we want to guess is high guess. And same thing, we're going to say, is your number this? But we need to add to it. So let's add to it. Let's say, actually, I'm going to do this a little bit differently. I'm going to print right here. I'm going to print, is your number this? And then I'm going to print some instructions. I'm going to say, can't type today. Not that I can type any other day. I'm a terrible, terrible typist. So we're just going to basically tell the user what to enter here. No. We don't want yes or no. This time we want high. H-I-G-H. And low. Okay, and then we need to get answer equals input, and we are going to print out a prompt. We're just going to make it, let's make it this right here. And then we're going to do answer equals answers.toUpper, and num guesses, we're going to add 1 to it because it's taking a new guess. Now we need to change this, though. Not a whole lot, but same thing. If the answer is yes, if they got it right, we're going to say guessed equals true. Go back up to the top. This test fails, and then we're going to print all this out. But we do now need to test for high and low. Yeah. So what I need to do here is I need to say if answer equals capital H. What do we want to do here if it's equal to capital H? We want to say high guess minus equals 1. Yeah, minus. No. High guess equals guess minus 1. I'm confusing myself. On a super easy little program here. All right. Then what we want to say is else low guess equals guess plus 1. I think that's it. I think it'll work. So let's talk about what we're doing here. So we're going to print out all the stuff. We're going to say, hey, here's your number, our guess. And our guess ranges from low guess to high guess. The first time through the loop, low guess is going to be equal to 1, high guess 100. So it's going to give us number from 1 to 100. And we don't need that. And then we're going to tell the user, enter Y for yes, H for high, L for low. Then we're going to get it into the variable called answer. We're going to print out a little colon for a prompt. We're going to convert it to upper. We're going to add 1 to the number of guesses because the computer is taking a guess. Then we're going to say, hey, if answer is equal to yes, set guessed equal to true because we got it right. Let's go up here and then this test fails and then come down here, print. I told you I would guess it. It took me and print out the number of guesses. Now, here's the change. If the answer equals H, that means we've guessed too high. So let's say the user enters, or the computer guesses 70. And we're sticking with our answer of 5, okay? Well, that's too high. We never want to guess 70 or above. So we're going to set the high guess value, the high guess that we can guess, the high value, equal to that guess, the previous guess, which was 70, minus 1, which would be 69. So that we can guess now numbers up to and including 69. Now, let's say we guess low, or the computer guesses low. For example, once again, let's stick with 5. Our number is 5. Let's say the computer guesses 4. Well, let me go lower. Let's say 2. We don't ever want to guess 2 again or lower. So we're going to set the low value equal to guess, which is 2, plus 1, 3. So now we can get values that are 3 or higher. All right, let's see if it works. Okay. Is your number 31? We're going to stick with 5. 5 will be our number. Is your number 31? No, they guessed high, so we're going to enter H. Is your number 14? No, that's too high. Let's enter H. Is your number 8? No, that's too high. Let's enter H. And so you'll notice it's never going above the value that we set as the high value. Is your number 1? No, that's too low. Is your number 6? No, that's too high. Is your number 4? No, that's too low. Is your number 5? Yes. And it got it in 7 guesses. Way, way, way better. I mean, way better than the 46 that it took before. All right, let's run it one more time. I bet we can get a little bit better. So let's go with 5 again. 5 will always be our number. Is your number 48? No, that's too high. Is your number 42? Life, the universe, and everything. But no, that's too high. Is your number 16? No, that's too high. Is your number 10? No, that's too high. Is your number 2? No, that's too low. Number 6? No, that's too high. Is your number 3? No, that's too low. Is your number 5? Yes. And we got it in 8 guesses that time. So one worse guess than before. So, wow, we have really gone a long way. We have improved our algorithm. So now I can define what an algorithm is. An algorithm is just a way of solving a problem. It's a list of steps, ordered list of steps to solve a problem. I'm sure that most of you have already used an algorithm before. For example, if you've ever used a recipe to make something, you've used an algorithm. It tells you what steps, what ingredients, what steps, how to mix them, when to mix them, how much to bake, how long to bake, what temperature to bake. That's an algorithm to solve a problem. So our first algorithm wasn't very good. It was just literally randomly guessed. And it wasn't very efficient. At best, it could have randomly guessed it on the first try. At worst, I don't even know what the worst is in that, because we're putting the value back in. We have exactly the same chance every single time through that guessing loop to guess the right number. That's not good. Our second algorithm was a little bit better. We took a guess. If it was wrong, we removed that value from the list of guesses that we could take. So we would never guess that number ever again. And that was better. Each time through the loop, we improve our chances of guessing the right number. Our third algorithm, this time, it was way better. I mean, our worst try was 8. And we're basically, our algorithm is guess a number, or set a low range and a high range. Guess a number. Ask if it's too high or too low. If it's too high, bring our high guess down so that we never ever guess above that number again. And then if it's too low, bring our low value up so that we're basically zeroing in on the number. And that improved drastically. But there's an even better way to do it. And it's called a binary search. So in a binary search, what we do is each time through the guess, we divide the list in half. So for example, the first time through, we're going to guess exactly halfway through. We're going to guess 50. Then we're going to ask, is that too high or too low? If it's too high, we know that our value is between 1 and 50. We're going to split the list in half again. So we now have two halves of the list, and our value is going to be in one of those two halves. And we're going to ask, is this too high or too low? Once again, whether it's too high or too low, we're going to take that range and split it in half again and again and again and again. I think the worst case scenario with 100 values is 7. 7 guesses is the worst case scenario, if I'm not mistaken. Somebody will probably correct me if I'm wrong. But let's write this. It doesn't actually require a great amount of change. All this is going to be the same, if I'm not mistaken. Let me get rid of that weird extra line there. So now when we take our guess is actually going to be... guess equals... now I know. So we don't need to guess randomly anymore. We do not need to guess randomly. Our guess is actually going to be low guess plus high guess divided by 2. So, for example, the first time through, and we're going to... This is important. We're not going to do divide by 2 like this, because that could result in a float value, a floating point. We don't want a floating point number. So we don't want to come up with half the list is 38.5 or something weird like that. The double division sign in Python is integer division in Python 3. So it's not going to give us a floating point value. All right, so now, let's see. I think the rest of it pretty much remains the same. That's the only thing we have to change them, if I'm not mistaken. Let's take a look. All right. So once again, let's go with 5. 5 is going to be our number. Is your number 50? No, that's too high. The next number it should guess is 25. Is your number 25? Now that's too high. So now guess is 12. You see, it's going halfway in between each time. No, that's too high. Is your number 6? No, that's too high. Is your number 3? Nope, that's too low. Is your number 4? Nope, that's too low. And so is your number 5? Yes. And we got it in 7 guesses. And if I'm not mistaken, I think that's the worst case scenario for this algorithm in with 100 values. All right, let's do it again. But I'm going to change my value this time. I'm going to go with 13. Let's go with 13. All right, that's too high. That's too high. That's too low. That's too high. That's too high. And there we got it. So this is awesome. We got it. We got a really good algorithm now. And it's going to guess it pretty quickly. Like I said, for 100 values, 7 is the worst case scenario. I want to do one last change to it. I want to do one last change. Let's time it. Okay, let's see how long it takes. So what we can do is, before we enter the loop, we can say start time equals time.time. It's just going to give us the time that we started at. Now, as soon as we guess it right, if we guessed it right, we're going to say end time equals time.time. And so now I can say something like print it took Oh, no, no, no. That's not what I want to do. That time's going to depend upon how much we answer. Oh, I know what we can do. Let's write an actual binary search algorithm. Okay, let's write an actual binary search algorithm. Let me see. I might tell you what I'm going to do. I'm going to write it real quick and I'll come back. That way I can shorten the video. I'll explain how the binary search algorithm works, and it'll shorten the video a little bit. So let me write it. I'll be right back. Okay. So I wrote it. It just took a few changes to our guessnum program, but I didn't want to take that time to write it online or during the video, just simply because the video is getting a little too long. Let me get rid of that. Okay, so I wrote it offline real quick. It's just some simple changes to our guessnum program. So you'll see that it's really kind of the same. And what we're going to do is we're going to create another list of numbers, that same num list that we had. This time I'm using the list comprehension. We're going to create it, a list from 1 to 100. Same thing, we're going to have num guesses. Now we're going to call this low search equals 0. And our high search is going to be the length of num list, because I'm going to show you we can actually change the length of it, so we can search for a number between 1 and 100. By the way, I forgot to mention, binary search only works if your list, or whatever you're searching through, is an ordered list. It can't be a random list. It has to be in order. All right, we're going to set a value called found to false. If we've basically, it's the same thing as our guessed value. And then we're going to say, hey, range is 0 to our high search, and num define equals what number to find. So we're going to ask the user, what number do you want to find in this list? We're going to start a little timer. We're going to say start equals time.time. So we're going to set the start of our loop equal to the start time. And then the loop is really about the same. The position is the position within the list. And it's just what we did before. It's low search plus high search. The low value plus the high value divided by 2. And for a list of numbers from 1 to 100, that low search is going to be 0. And the high search value is going to be 100. That's a little bit different than what we were doing before, because now we're actually searching through the list. We're going to search, and remember the list begins at 0. Position 0. So position 0 is number 1, value number 1, or value number 1. Position 1 is going to hold the number 2. Position 3 is going to hold the number 2. I'll show you in just a minute. We're going to add 1 to our guesses. Now, if num list position equals num defined, in other words, if the value in our list at this position is the number we want to find, we're going to set our end time. We're going to set value to true, exit out of the while loop, and do our end stuff. However, if num list position, if the value that's at this position is greater than the number to find, we're going to take our high search value, set it to that position minus 1. And same thing with the low search values. It's exactly what we were doing before. So let's run this. All right. So we've got a range from 0 to 100. Let's find 5. I found it. It was in position number 4. So remember, okay, the value 5 is going to be in position number 4, because this is position 0, position 1, position 2, position 3. Position 4 is going to hold the value of 5. So it found our number 5 in position 4 of our list. It took 7 guesses to find it in a really, really short amount of time. That's not 4.5 seconds. That's 4.5. Basically, this E to the negative 5 means move that decimal place 5 places to the left. So what is that? 0.000045. So an incredibly short amount of time. Binary searches are actually pretty quick. Let's add a couple zeros to this. So now our range goes from 1 to, what is that? Is that 100,000? Yeah. So let's find the number, I don't know, 234,871. Oh no! List index out of range. I must have put in, oh, I did. Oh my God. Wow. 200,000 is above 100,000. So you see we get an error if we go above. All right. Let's go with, I don't know, 57,643. And it found it. And look at how long it took. 0.0001 seconds. Super quick. Let's add another zero. Let's add 2 zeros. Raspberry Pi, I hope we don't run out of memory here. Let's see here. Oh, nope. So let's see here. That's 1, 2, 3. 1, 2, 3. So that's 10 million. Let's go with 7,892,561. Once again, pretty fast. It found it in 23 guesses. It just took 23 guesses to find it, and it took 0.00012 seconds. Incredibly fast. Okay. If you got any questions about what we did, put them down in the comments. I'll try to get to them and answer them. So let's take a look at our learning goals. Let's make sure that we covered everything that I wanted to cover. All right, so our learning goals were, by the end of this video, we're going to understand what an algorithm is. And we explained that. An algorithm is essentially just a set of steps to solve a problem. And we went through a couple different algorithms to search for this number that we had chosen, or for our computer to search for that number. We went from some algorithms that were not good at all, they're a completely random algorithm, and then building up from there to the binary search algorithm, which was really efficient or really fast. So understand what a binary search is, and we did that, compared it to some other searching methods, such as a sequential search. I didn't go through the sequential search. We did a couple other searches, but a sequential search is basically going through the list one element at a time. And I think that you could see how inefficient that would be also. Similar to our one where we removed a list element every time. In the worst case scenario, we have to search the entire list to find that number. I showed you a little bit about importing the random module and the time module. And we used the randint and the choice functions from that module. And we learned a tiny little bit about list. Lists are one of the most important or most powerful things in Python. And I'll probably do a whole video about list later on. So if you have any questions, put them down there in the comments. Once again, please like the video. Please subscribe. I would really appreciate it. And until then, every day is a great day to learn how to code. And I'll see you next time. In fact, the next video, little preview, we're going to do some stuff with Pygame, learning a little bit about game programming. So goodbye.